Hello dear student. In the last lecture, we have learned about microcontrollers. In this lecture, we are going to discuss briefly the broad range of commercially available microcontroller chips. This is lecture number 4 of Elements of Embedded Systems. In this video, we will look into different classification of microcontrollers, different families of microcontrollers from various manufacturers. In particular, we will look into the families of Intel, the Freescale semiconductor, that is a family from Motorola, and also from ARM. Microcontrollers are categorized regarding the bus width, the instruction set, and memory structure. For the same family, there may be different forms with different sources. In this video, we will describe some of the basic microcontrollers that are new and are well known to the people around. The types of microcontrollers here shown in this figure are categorized by their bits, that is, they can be 4-bit, 8-bit, 16-bit or 32-bit microcontrollers. They can be categorized based on their memory or their devices, that is, if they have an external memory or a memory embedded in the system itself, such like system on the chip SoC like that. Or it can be categorized based on their instruction set, such as if they have a CISC 6 instruction set, that is complex instruction set computer, or whether it have a RISC instruction set, reduced instruction set computer embedded on them. It can also be classified on the basis of their memory architecture, whether they have a Princeton memory architecture or a Harvard memory architecture. Different microcontroller families are available. We have microcontroller families such as 8051 from Intel, there is Motorola, there is PIC, Texas, National, ARM, and many others. 8051, it's also mainly from Intel, ATML, Dallas, Philip, Siemens, and there are a whole school of microcontrollers available nowadays. In this lecture video, we will be focusing more on the Intel microcontroller 8051, the Motorola microcontroller, that is mainly the Freescale semiconductors, and also the ARM microcontrollers. The microcontrollers based on Intel 8051. In early 1980s, Intel Corporation introduced a microcontroller chip called 8051. This chip has basic architecture of Intel's 8080 microprocessor family, which used 8-bit chips for general purpose computing applications. The 8051 chip gained rapid popularity and has become one of the most widely used chips in practice. It has 4 8-bit input-output port, a UART, and 2 16-bit counter or timer circuits, as we have discussed in our last video. It also contains 4K bytes of ROM, or 128 bytes of RAM storage. The EEPROM version of the chip, in which there are 4K bytes of EEPROM rather than ROM, is available under the name 8751. A number of other chips based on 8051 architectures are available. They provide various enhancements. For example, 8052 chip has 8K bytes of ROM and 256 bytes of RAM, as well as an extra counter or timer circuit. Its EEPROM version is called 8752. 8051 architecture has developed by Intel. Subsequently, a number of other semiconductor manufacturers have produced chips that are either identical to those in 8051 families or have some enhanced features but are otherwise fully compatible with 8051. The Freescale semiconductor. Freescale microcontrollers. Motorola has a dominant position as a manufacturer of microprocessor chips in the 1980s. Their most popular 8-bit microprocessor became the basis of their microcontrollers. Freescale Semiconductor is Motorola's successor in this area. Freescale manufactures a wide range of microcontrollers based on different processor cores. 68HC11 microcontroller. Motorola's most popular 8-bit microprocessors were in 6800 and 6809. The 68HC11 was introduced as a microcontroller chip that implements a superset of 6800 instructions. It has 5 input-output ports that was used for a variety of purposes. The input-output structure includes 2 serial interfaces. There are also counter or timer circuits capable of operating in a number of different modes. The amount of memory included in 68HC11 chips ranges from a 8K byte ROM, a 512 byte EEPROM, and a 256 byte RAM on the original chip to 12K byte ROM and 512 byte EEPROM and 512 byte RAM in the later chips. 68K microcontrollers. A family of microcontrollers known as 68K is introduced, and it is based on the 32-bit 68000 processor core. To reduce the number of pins, an external data bus has only 16 bits wide. These chips include parallel and serial ports, counter or timer capability, and also AD conversion circuits. The amount of on-chip memory depends on a particular chip. For example, 68376 chip has a 8K byte EEPROM and 4K byte RAM. The cold fire microcontrollers. The 68000 instruction set architecture provides a base for the 62-bit cold fire microcontroller and the MCF5XXX microcontrollers known as the cold fire embedded processor. Their distinguishing features is a pipeline structure that led to enhanced performance. The external bus width may be 16 bits to 32 bits depending on the selected microcontroller chip. The coal-fire processor core is also intended to use the system-on-chip environment. The PowerPC microcontrollers. Freescale high-end 32-bit microcontroller family known as PowerPC is based on RISC-style architecture. The processor architecture is also available in microcontroller form, in chip comprising the MP35XX family. The ARM microcontrollers. The ARM architecture is used for embedded system where substantial computing capability is needed and the cost and power consumption have to be relatively low. A key objective of design of ARM microprocessor is to make it suitable for the use of system-on-chip environment. ARM microcontrollers are also available as separate chips. There has been a progression of ARM processor cores intended for embedded applications including ARM6, ARM7, ARM9, ARM10 and ARM Cortex. The basic ARM architecture uses a 32-bit organization and an instruction set in which all instructions are 32-bit long. There exists another version known as Thumb, which uses 16-bit instruction and 16-bit data transfer. The thumb version uses a subset of ARM instructions which are encoded to fit into 16-bit format. It also has fewer registers than ARM architecture. An advantage of thumb is that the significantly smaller memory is needed to store programs that comprise highly encoded 16-bit instruction. At execution time, each thumb instruction is expanded to normal 32-bit ARM instruction. Thus, a thumbware ARM core contains a thumb decompressor in addition to its normal circuits. Therefore, in this video, we have learned about microcontroller families. The given is a book I have referred to. Thank you for watching.